Let's look at the power reduction formulas. These formulas take something that is squared and reduce it to something that is not squared. Now, these formulas honestly are very rarely used. Most of the time, if you see something squared, it means you're going to do something with a trig identity about it. However, very rarely, sometimes we want to take powers and reduce them down, like we have in example 4. We want to rewrite sine squared of theta, cosine squared of theta, as a sum and or difference of cosines to the first power. So sine squared of theta is going to become this. Cosine squared of theta becomes this. And let's simplify. I notice that if I multiply the numerators together, I have difference of squares right there. So that's going to be 1 minus cosine 2 theta plus cosine 2 theta, which will cancel, minus cosine squared of 2 theta. And if I multiply straight across in the denominators, 2 times 2 gives me 4. However, the instructions in this problem said to bring them to cosines to the first power. This still is not a cosine to the first power. This is a cosine squared. So here's what I'm going to do. I'm going to use the cosine squared formula again, but this time I'm putting 2 theta here. So if I put 2 theta here, that would make this inside 4 theta. It's still doubled. So we get 1 plus cosine of 4 theta all over 2. Let's combine some like terms. To do that, I need a common denominator, so I'll change that 1 to 2 over 2. And then I can combine my numerators all over my common denominator of 2, all over that 4. Now, hey, that's just 2 minus 1, so I can simplify that to just 1. And now I can do keep, switch, flip. Which gives me that. And now I have taken things that had squareds and reduced it to cosines that didn't have any squareds in them. And that is an example of your power reduction identities. Remember, they don't come up very often. They're pretty rare, but you do need to know them. So we will have one last video of the day where we'll take everything we've learned and we'll do one last trig identity proof with it.